Okay, so we've already talked about this situation. So this is simply part D of an FRQ we started discussing on the gold packet. Part D says, at what time between 9 and 23 does this model predict that the number of people in the park is a maximum? Okay, stop there. That statement should be reminding you of what we call the Min Max Theorem. Something I want you to always do. They're asking you to figure out when the number of people in the park is greatest, but they don't give a symbol for the number of people in the park. So unless you like to write over and over again the number of people in the park, just invent a symbol so you can stop writing that long, tedious phrase. So on your paper you should write N of T equals number of people in the park. Cool. Okay. Min Max Theorem says N of T is greatest or least at the beginning time, the ending time, that's a really interesting 3, beginning time, the ending time, or when the derivative of n is equal to 0 or undefined. So I remember the Min Max Theorem.
Is it legal to say like when n of t is like the relative maximum?
Yes, it is legal to do that because the Min Max Theorem is basically saying exactly what Josh said. N is going to be either greatest, where n has a relative max, or n could be greatest at the endpoints. That's the Min Max Theorem. There's a reason I have you write this, though. I like what you said. I would not forget that. They're going to give me points for remembering this, so don't want to forget that. Good questions? Okay, this has to be a flashcard memory. I don't have an easy way to remember that other than just flashcard, the Min Max Theorem. Once I write the Min Max Theorem, or once I remember the Min Max Theorem, it triggers what I should do next. What I need is I need to go, like, look, the way I'm thinking is this. The park opens at 9, it closes at hour 23. At one of the times in between, of which there are many times in between, the amount of people in the park will be highest. Well, I don't want to go searching through all the possible times. I want to just look at a few times. So I know time 9 could be it, although not likely since at time equal 9 there are no people in the park. So, okay. But in some other problem, that could be where the value is highest. I got to go figure out this. I need to figure out when n prime is 0. So I need an equation for n prime. Pretty sure we discussed how to come up with the equation for n prime last time. If not, no one will raise their hand, but raise your hand if you know the equation for n prime. Here we go. And this is always the equation. Every time they give you a situation where there is a rate which causes n to go up, I call that the in rate. And then there's an equation, a rate which causes n to go down, I call that the out rate. I can always find n prime, the overall rate at which n is changing. Christian?
Isn't it the function of e of t subtracted by the function of l of t?
Perfect. The rate at which n changes is always the in rate subtract the out rate. Hands up, who knew it? 2 points, 3 for Christian. Question? Okay, as always, the goal here is to get you to do the thinking, not me. So based on what is written on the board, feel free to talk to each other, but raise your hand and tell me, what would you suggest we do next? Like, think about what they want us to find. Think about how the Min Max Theorem helps us find the answer. Think about what we've written, and then logically put the clues together and say, oh, if these are the clues and my goal is to find where n is greatest, hey, a smart thing to do next would be this. Talk for a minute, go.
So we all know that the derivative of 0
I should say we plug 0 in for no, n prime of 2 would equal 0, but n small of 2 would be 7. You could plug in 23 for t, or 9, but 9 is 23.
Okay, heads up. What do we do next? Come on. Hoping for a few more heads. What do we do next? Tori? So how many agree that based on what we see, based on what we're trying to accomplish, a very logical next step would be to figure out where n prime is equal to 0? Point 3 for Tori. Look over here, please. My goal here is this. I do think you're going to have a flashcard to remind you of the Min Max Theorem. That you're reading the problem, it says find where n is greatest, and your brain says, got it. The answer to this problem is either the beginning time, the ending time, or somewhere where the derivative of n is equal to 0. But once you remember that, I don't need another flashcard. The next step is just logic. It's like, oh, I got to go figure out when n prime is 0. So I need this on my calculator. Here's how I graph n prime. Yes. Do you not have one ever, or you just have it at home? You don't have it in schools, or you don't have it at schools? In my opinion, this is the best thing to do. I always put the in rate in Y1. I always put the out rate in Y2. If you make the formula longer, it's easier to make a mistake. So So just put in rate in Y1, out rate in Y2. Usually when you're doing the FRQ, you need them separate anyway. Then on Y3, I need to change the color here. Hold on. On Y3, let's save that. Really unuseful machine. Okay, so back to here, sorry. So in Y3, I'm going to put the in rate subtract the out rate.
Can you simply do
Like this.
Y2 minus or Y1 minus?
So that's what I would do. And then I'm going to turn off the in rate and the out rate, because I only want to see the graph of n prime. So we need me to help you with that? Cool. Window 9 to 23 is the time period. Zoom fit. Can you look at their calculator? Okay, raise your hand. What points should I be looking at on this graph? Hands up, come on. Just got to think with me, don't just watch. What points should I be thinking about as I look at this graph? So Zach?
The graph is like at x equals 0.
Y equals 0, actually. So are you looking here?
Yeah.
How many is looking here? 0.2 for Zach. So I find the 0. Make sure it says 0. Then I have to store that. I can't just write it down. So I second quit. I'm storing the x coordinate. I'm going to put it in A. I make sure that's the right value. I look here. Yep, that's right. So over here I'm going to write it down. So I write on my paper, n prime of t is equal to 0 at t equal 15.795 and I have stored that in A. Okay, the 3 red arrows are required, the blue is extra. If I don't have all 3 of the red lines, if I don't have all 3 lines that are indicated with the red arrow, I will lose the point. And on this test, you'd lose 3 points because the scale is much bigger. So, question, please.
You round it to 16, okay?
Never round until the end. So never, 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 never round unless, well, actually never round unless they tell you. And then only at the end. So, 2 points.
So like I just put n prime of 15.795 0.
Same thing, that's fine. Yeah, so the way Josh wrote that is exactly equivalent to this statement. That'd be fine. 2 points, please, Charles.
I just found the intersection of L and E. Is there a problem to doing it that way? Or?
No, that works as well. You have to make sure you write down that you did that. So you'd have to write something like this. E of t is equal to L of t at t equal, because part of what you're getting points for here is proper justification. So if you write this in blue, that's exactly equivalent to the red. Okay, 2 points. One out. Cool. Okay, so there's only 3 possible times that can be the answer. Okay? All that's left to do is find out how many people are in the park at each of those 3 times, and then we'll know when the park has its greatest number of people. So, I just do integrals. N of 9 is given as 0. To find the number of people at time A, I need to integrate the rate at which n is changing, because whenever fundamental theorem again, whenever I integrate the rate at which n changes, I find out how much n changed. So this integral is telling me from time 9 until time A, n will change by nearly 4,000. Well, n was 0 at time 9. So because the change in n is 3,951, that's how many are in the park at time A. You need me to say that again, say it differently, talk about it.
Why are we having A be the final?
So I don't really like writing the number. Well, really it's so I remember to store it. So a rule of the test is, 2 for Elena, I calculated this with my calculator. I am not allowed to use this value. I have to use the value that is in the calculator. So I have to use A. But what I'm really saying is that from 9 o'clock in the morning, okay, hour 15 is 3 o'clock, hour 16 is 4 o'clock. So pretty close to 4 o'clock because it's 15.795. So from 9 in the morning until 4 in the afternoon, the number in the park will change by some value. When you integrate the rate, that's the rhyme, when you integrate the rate at which n is changing, you find out how much n changed. So n changed by this amount during the time period 9 in the morning until roughly 4 in the afternoon. I'm not sure that was your question though.
No, yeah. How come we stop at that? Does that make sense?
Keep talking.
Do we have to? How come we're not finding after 15 to 23? Does that make sense?
You don't stop talking. Are you think I should put a 15 here?
Yeah. An A then? How come we're only going from 9 to 15? I guess we're going 9 to 20 there.
You have a good question. I'm just searching for a way to help you more. Don't stop talking. Say it again.
Maybe I'm just seeing it wrong.
You are
Yeah.
You are seeing it incorrectly. I'm trying to find a way to help you see it correctly. So you just have to keep talking.
So I'm just seeing the graph. From us going from 9 to 8 of
Let me say something back to you. See if this helps. So what does n represent?
N is the N of t or just N?
Either way, n of t.
It's the number of people in the park.
Good. So everybody over here, I want everyone in on this one. Raise your hand and answer this. If n represents number of people in the park, when you integrate n prime over any time period, what are you finding? Hands up. Come on. This is the fundamental theorem. There is nothing on the AP test tested more than the fundamental theorem. N represents, you've got to be able to say this. You can't just listen to other people say it. I'm not kidding. You have to be able to say this. N is the number of people in the park. If you integrate n prime, what are you finding? This is the fundamental theorem. It never changes. It shows up on 30% of the entire AP test. Talk, come on. You got to be able to say this. You all have to be able to say it. Here we go. Look up. Come on, look at me. Like really, look over here. Come on, look over here. So the question is, and I'm really serious, like on the AP test there's 108 points possible. About 30 of them come from understanding the fundamental theorem. So what Elaine is digging for, 3 points for asking, take 4, it's really good, is it's got to be clear to you, it's got to feel right. And she can tell it doesn't feel right, so it's bugging her. And that's why we got to talk about it. So raise your hand and answer this. If n is the number of people in the park, when I integrate n prime, what am I calculating? Calvin?
Is it like the rate of like people entering or leaving the park?
2 points, let me say it back to you. So n prime itself is the rate at which people enter or leave the park. Like n prime is the rate at which n changes. Look at me. Think of the number of people in the park as a indicator like this. Like this is how many are in the park. If the number in the park is going up, this is going to rise. The number in the park is going down, this is going to fall. N prime is how fast this goes up and this goes down. That's what n prime is. N is the level itself. Like n's how many are there. N prime is how fast this goes up and down. When we integrate n prime, we're not finding the rate. Like n prime is already the rate. The fundamental theorem says if you integrate the rate at which n is changing, what do you always find? Hands up again, come on. If you integrate the rate at which n is changing, what are you always finding, Julia?
The number of people in the park or just
You're okay. No, stay. Everybody, look, stick with this. Don't look. Focus. Come on. 3 points for Julia. That's a common mistake because it's sometimes right, but sometimes not right. So I'm trying to teach you what is always correct. N is the number of people in the park. N prime is the rate at which n goes up and down. When you integrate n prime, what do you always find without any exception? When you integrate n prime, what do you always find, Lauren?
Like the amount?
You're kind of thinking like Julia. It's true that when we start with the rate and we integrate, it's Danica's chart. We're over here, we have a rate, n prime, and we integrate that rate, we are headed towards an amount. But you have to be cautious. It's not necessarily the amount, but it's always something I'm trying to get you to say. Ashley.
Is it the rate that n is changing?
No, that's what n prime is. Like you're kind of thinking like Calvin.
Yeah.
It's okay. Yeah, n is the amount of people. N is the level of people in the park. N prime is the rate at which this level goes up and down. So n prime is the rate. When you integrate the rate, that's the rhyme I always refer to, and it's apparently not helping anybody. If you integrate the rate, what do you always find, Ashley?
How much n is changing?
Okay, everybody put your hand down. Somewhat luck because I called on her and others knew it, but oh well. Sometimes life is about luck. Listen. There you go. Right down the helms. Okay, all of you, you've got to get, think of it, 108 points on the AP test, 30 of them come from what we are talking about at this moment. N prime is the rate at which n changes. So n prime tells me how fast this level goes up and how fast this level goes down. But when I integrate the rate, when I integrate n prime, I am always finding how much did n change. How much did the level change? Okay? So at time 9, say it out loud, please. What is n? Say it.
0.
Louder. 0. At time 9, n is 0. I'm going to integrate n prime, the rate of n, for the next 9 to 4 o'clock. So that's whatever, 7 hours, right? In that 7-hour period, n will change. This is how much n changed. But n was 0. So if n changed by 4,000, I now know what n is. So this is why I was saying, Lauren and Julia, you have to be a little careful about saying amount, because it kind of depends on what this number is. You don't integrate necessarily get the amount, it depends, but you always get the change.
So is it because the intervals are different? So at 9 and 23, if that's the interval, it wouldn't necessarily be counted in number of people, but how much it changed? Is that what you're saying?
Close. Let's keep talking until it feels better. You're really close. Look here. This integral's value is 1. Hands up. What does that mean? Come on, hands. Because we took 0 plus the integral. So 0 plus the integral is 1. That means the integral is 1. So what does it mean that this integral's value is 1? Don't be afraid. Just you're far ahead to raise your hand and say something wrong than to not say anything. I guarantee you. What does the integral's value equaling 1 mean, Sophie?
That from time 9 to time 23, the amount changed by 1.
Say it again.
From time 9 to time 23, the amount changed by 1.
Perfect. Okay. Look, calculus. You all know this. You've been in class now for two terms. Is about precision, right? The difference between scoring 91 on the test and scoring 61 on the test isn't that your understanding's way off. It's like just a little bit off. And suddenly you miss lots of things. When you integrate n prime, you're finding how much n has changed. Now watch my hand. What's the level in the park at time 0? Say it. 0. Ah, shoot. Level in the park at time 9. 0. There we go. Sorry. Okay. People enter the park, people leave the park. So watch what happens. The level's going to go up, and the level might go back down, the level might go up again, go back down, go up, whatever. By the time we get to hour 23, the level has come all the way back down. So from time 9 to time 23, the level only changed by 1. It doesn't mean that during that time it wasn't way higher and way lower, but just comparing those two times, this is the result. That for that entire time period, that's how much n has changed from this time to this time. That might have been what was mixing up.
Yeah.
Does that sound better?
Yeah.
Yeah, I could tell. Look, right? I said it. See, that's my fault, not yours, because I didn't say it in a way that made better sense. Fair? Yeah. So from 9 until hour 23, this is the change. In between, there are all other kinds of things happening. Please.
So it's just because we know that A is the relative max, like taking back to the Min Max Theorem. So like from the beginning to the max, it changed that much. And then from the whole thing, it changed.
Yeah, I think what was mixing up Elena was, it's just the English language always causes trouble. Because it's kind of how you think of it. And then we just got to make the words match. That you could think of it as like, well, no, the change wasn't 1. Like it went way high and way low, so the change was a whole bunch. No, just between these two times, that's the difference. You know. Please.
So is that 0 that we're adding to the integral, is that just the amount that we started? So say it started at like 12, would that be just a number at that?
Yes. So let me say it back and see if this feels good. Look, at time 9, there is no one in the park. This integral is telling me that the difference between like how much n changes from time 9 until time 23 is just 1. That means there's one person at time 23.
Will I lose points if I don't have that 0?
No, you don't have to write this. Please.
Wait, at time equals 23, is it 0?
At time equal 23, there's one person in the park.
So,
Because this is going to tell you
at time equals 9,
there's nobody there. And then 20, I can't do it in my head, 14 hours, how many hours later is it? 14, yeah. 14 hours later, how do I say this? The integral's telling you how much n will change during that time. But not like moment by moment. It's like the net change.
Yeah, like the overall.
The overall change in n from that time to that time is just 1.
So at time equals 23, that means there's one person in the park.
So what?
At time equals 23, there's one person.
There's one person in the park.
Oh, okay.
This says the number of people in the park at hour 23 is 1. I think, I feel like I know what was messing you up, and I don't know how to say it better is my problem. It's like when we say the change in n, we're not talking about adding up all the change, but we kind of are. It's confusing. Because literally that's what happens, is you say, I don't know, maybe this would help. We should just stop talking about it. This is a graph of n prime. Yannick's chart says that when n prime is positive, n will go up. So until hour 15.75, n is going up. But when n prime is negative, n goes down. So for the rest of the day, n is falling. So you're better? Okay, good work. Yeah. Okay, all of you need to say what Sophie said. When you integrate n prime, you find how much n has changed. That is the fundamental theorem. That will never, that's it. It never changes. When you integrate n prime, you find out how much n has changed. When you integrate the derivative of anything, you find out how much the anything changed. Okay? That's the fundamental theorem. This might have helped too, Elena. Can I give you a ticker? Hold on. Help me for one more thing. All of you look at this. Okay, Sophie said correctly that this integral finds how much n has changed. The fundamental theorem states that there are two ways to calculate how much n has changed. So one way to calculate how much n changes from hour 9 to hour 23 is to integrate n prime. But the fundamental theorem tells you there is another way to identify how much n has changed from hour 9 to hour 23. Hands up. What's the other way? It's much easier. It's simpler. It's like lots of, like you don't have to know calculus to know the other way. Like what's the other way of knowing how much did n change from hour 9 to hour 23? What's the other way? Come on, hands. More people know this than are raising their hands. What's the other way of knowing how much n changed from hour 9 until hour 23? Don't overthink it. So Rachel.
You subtract n of 23 from, or you subtract n of 9 from n of 23.
You simply compare how many people are in the park at hour 23 with how many people are in the park at hour 9. Raise your hand if it was raised and you were ready to say that. 2 points. Okay, 3 for Rachel. So I probably should have gone here first, Elena. This is the fundamental theorem. This is pretty easy to understand. I just compare how many are in the park at the end versus how many are in the beginning, and that will tell me how much did that number change between those two times. You don't care what happened in between. You're just comparing those two times. But the integral does the same thing. It calculates how much did n change. That's the fundamental theorem. And then all we did is rearrange this. We said, oh, put the n of 9 over here. So n of 23 is equal to, I hate that. So n of 23 is equal to n of 9 plus the integral from 9 to 23 of n prime. That's all we did. So, question? Awesome. Back to here. Then you simply answer the question. This information right here is worth 1 point on the actual AP test. On my test, it will be worth 3 points. This information here is worth 1 point on the actual AP test. On my test, it will be worth 3 points.
So I kind of broke up the formula. I said the most people in the park at time equals T equals A, and then I had another sentence that says the amount of people in the park is 3,151 at time equals A.
That'd be totally fine. Yeah, if you wrote exactly what you said, perfect.
So like you might do this in a different way.
Oh, just make sure you put the word hours with the time. Go ahead, please.
So like in a different equation, how would you find like how do you know which one's bigger? Like, say, this one told us right away that at 9, there's no one in the park or whatever. Like, if there are already people in the park, how would you know which one was greater between the beginning and the end?
Oh, you don't care. The convention we will always use is we'll always compare final minus initial. Is that what you meant? Yeah, we don't really pay attention to bigger or less. We just would say, you always write the integral from left to right, and then it's always, this number always goes here, this number always goes here. Is that what you meant?
Kind of, but like, you can try to find, like, for like the relative min or max. So it's either at the beginning or the end or the relative max. So, like, we knew it wasn't at the beginning because it said it's a 0, but like, if it had some value.
Oh, let me say this, sit this out. No, we'll keep talking, Josh. 2 points. Everybody look up. Okay, again, we are obviously not trying to solve this problem. We're trying to understand how to find the max of anything. And the pattern is the same. The max of whatever is going to be at the beginning time, the ending time, or where the derivative of what we are maximizing is 0. So I go figure out where the derivative of what we're maximizing is equal to 0. I've got that. Now all I have to do is write down what is the value of n at each of those times. So in some future problem, this is going to be n of 9 equals 5,000.
You could just use the fundamental theorem just to calculate that if you needed to.
And at time A is going to be 5,000 plus how much did n change over that time period? N of 23 is going to be 5,000 plus how much did n change? And then all you're doing is comparing these numbers and identifying which of these 3 is the greatest. Does that make sense? Yeah. There, question. Okay. Please, Joe.
One more question. So we told the grader that A equals the time, and so when I'm writing out like the amount of people apart, can I just write A because I told them that, or should I write the number out?
You can write A, but then you have a tendency to forget to write the units, which can cost you. So I always write the number because I want to remember the unit.
Is this to round to a near whole number? Is that for people? Or would that be
2 points for Dawson and 2 for Justin. This is where, again, you cannot read. You're doing great. You cannot read quickly. You have to read really carefully. It says specifically, at what time does the model predict that the number of people in the park is a maximum? Nowhere in that question did they say to round the time. So I did not round the time in my final answer. I keep reading carefully. Rounded to the nearest whole number, what is the number of people in the park at that time? So I do have to round the number of people. So this purple statement is worth 1 point on the actual AP test, 3 points on my test. And if you round the hours, you lose the point. Like on my test, it's not like you get 2 out of the 3. It's 3 or nothing, just like the multiple choice. So if you round this, you lose all 3. If you forget to round this, you lose all 3. If you forget to say hours, you lose all 3. It's 3 or nothing. Is that your question? Point. Anybody else? Please.
Well, the answer for these questions always like be a logical answer. Like we won't get like a negative amount of people, right? Our final.
I've never seen that happen.
Okay.
No, I've never seen them give you a model that misbehaves.
Okay.
Like that gives predictions like, well, that doesn't make any sense.
It's like,
I've never seen that.
So if we find if we do get an answer that like would make sense.
You've done something wrong.
Okay.
Yeah. Now, you will encounter problems where maybe they're talking about a moving particle, and you're trying to find like where the position is greatest. Well, that could be negative, because the position being negative just means I'm to the left of the origin, so that would make sense.
Okay.
Anybody else? Cool, next thing. Key number 2. You talk to each other and raise your hand and tell me what's the first thing I should write on the board. It's an FRQ, so I have to write down the right things or I don't get the points. So talk to each other and then raise your hand and tell me what should I write. good. Charles found his water bottle. All right. I forgot who it was. I found out. I couldn't remember who it was. Hands up. What do I write? Just the first thing. I don't need all the things. I just need one thing. Come on. What's the first thing to write? Let's go, Hallie.
P of t will be lowest when t is 0. P prime of t equals 0, or when t equals infinity.
P of t is lowest at t equals 0, t equal infinity, or where p prime of t is equal to 0. Who had their hand raised and was prepared to say that? Points 3 for Howard. Questions?
I was going to say like P of t is an amount, like the amount.
Oh, gotcha. Nothing wrong with stating that. 2 points for that. They actually say that here, so I don't have to. They say the number of gallons P of t of a pollutant in the lake. So that one I don't have to this time. The last time I had to because they didn't give the symbol n. So, questions? Please.
How do you want to figure out yourself the time?
Yeah, really good question. 2 points for Tori. You either have to be really good at being able to analyze a function without a calculator, which I'm not. Most people aren't. Or you just guess and check. So I grab my calculator and let's see, this is 2B number 2. So what I do, Tori, is so I've got P prime entered. I hit window. My first guess is, I know to start at 0. Are you okay with that? I always guess 5, just see what happens. Now, I can hit the on key and stop the graph right now to save some time, because immediately I notice that these tick marks mean the x-axis is up here, and I can't see the x-axis. So my graph isn't going to cross the x-axis. So I need it bigger. So I just start again, and I kind of just double it. So I go to 10, zoom fit. Right away, I see the same problem, so I stop it right away.
How do you stop it?
Press the on key. So just guess again.
We're looking to have the x-axis on our graph.
Yeah, because remember right here, 2 for Sydney, we're looking for P prime is 0. Yeah, and I'm graphing P prime, and I can't see where P prime is 0 because it's not showing the x-axis. So I guess 20, zoom fit again. And my cursor at AP writers. Stop again. 50 words. 40 words. Yeah, there we go. Question? Anyone find the 0 already? Allie, what'd you get?
30.174.
So I come over here and I say P prime of t is equal to 0 at t equal 30.174.
Yep.
Thank you. And then I store that in A. Points for Hallie. Question? Talk to each other and look. Oh yeah, please.
I guess I don't know why I don't get this, but why is it P prime of t? We never found the derivative of this. Oh wait, never mind. I get it. So they gave us these.
Right, they just gave it to us in this case.
I thought they gave us.
You're okay. No, just read carefully. You're okay. 2 points. Yeah. Okay, talk to each other, raise your hand, and tell me what's the next thing I should write. Come on. Look at your notes, talk, whatever. Just hands up. What do I write now? What should I, and you don't have to know everything I write. I just want you to raise your hand and tell me one thing I should write. Success on the AP test is about writing one thing, see what you wrote, and then you think of the next thing. Success doesn't come by knowing how to write everything all at once. Just one thing at a time. Hoping for either more conversation or more hands. So. Silence is not what I was hoping for, so yeah, you know. You integrate P prime, you find the change in P. Yep. You integrate P prime, you find the change in P. The words all fit together. P prime is the rate of change of P. So if I integrate the rate of change of P, I find out how much P changes.
So would you do the integral?
I didn't know.
Would you do the integral from 0 to A?
Seriously, you might as well speak Portuguese. It can be about as helpful. Chinese, Martian, language of the Wookiees from Star Wars, or whatever, you know. Who can tell me what to write? Justin, go ahead.
As you do P of 0 equals P down.
For sure. Because I know that P could be greatest at time 0. So I want to keep track of that. 2 points for Justin. Now what would I write? Please, Abby.
P of t equals integral 0 to t p prime of t times p of t plus 50.
Okay, hold on. It's really smart. I'm going to give Abby a ticket for this one. What Abby is noticing is that she can find the amount of pollutant in the lake at any time. All you have to do is say, look, at time 0, there's already 50. If I integrate from that time to whatever time I want, I'll find how much the level changes from that time to whatever time I want. Adding that to 50 will tell me what the new level is. That's this equation. This is extremely valuable to know. So this will find the level at any time. Now there's one little gotcha here, everybody. So all eyes are on me, waiting for everybody to look up. So Lizzie, look up in just a second. You're doing price one. Don't want to miss this. This is one of those things that sometimes they'll take off a point, sometimes they won't. But I would rather you not lose a point, okay, for something simple. Everyone's going to answer this question. What does this T represent? Hands up. Come on. You all know. What does this T represent right here? What does this T represent right here? So Carson?
Time in hours.
This is a time in hours. Is it like all time or a specific time?
Specific time.
Specific time. You're going to choose. I want to find the pollution level at time 10. And then you put a 10 right here. How many knew that? 0.2 for Carson. Where else in this equation would you put a 10? Hands up. Come on. If I'm trying to find the pollution level at hour on day 10, I need to put a 10 here. Where else do I have to put 10? Let's go, Sarah.
Value
Right here.
Yeah.
How many agree that there should be a 10 here? And there should also be a 10 here. 2 points. 2 for Sarah. The 10 doesn't actually go here. So it goes here. Where else does the 10 go? Hands. Koji?
P of t at the left hand.
Yeah, so I have to put it here. So I have to say P of 10. I have to put a 10 here. 2 for Koji. You do not put a 10 here. Okay, this T represents something different than this T. Who knows what this T represents? So this T represents 10. But this T is different. Josh?
So like that T is like 0.00001 for like 1,000 for this, whatever. And then like it would be, so let's say velocity at that point, and then like add 0.0001, and then like, so it's just the amount of, that's the velocity at that time, the rate at that time.
Let me say it back to you. 2 points. This time is actually a million different times. When you perform the integral, this starts out at 0, it then becomes 0.00001, then 0.00002, on and on and on and on. Okay?
So I thought that was the point of dt. I thought that was.
Oh, dt is just 0.00001. So dt is a difference in time. And it's ideally a very short difference in time. The t here is every single moment in time between hour 0, day 0, and day 10.
So what's the point of having dt?
It's how long. It's like, here's your rate. This is the idea. If the rate is 2 gallons per day, but that's the rate only for 1/10 of a day, then when those two multiply together, you find out that in that 1/10 of a day, the amount would change by, the amount of pollution would change by simply 0.2 gallons. This is the dt.
Oh, okay.
It's how long does this rate last.
Okay, so that's kind of like just the time period.
This is the time period.
Cool. Okay.
This is the rate at lots of different times.
Yeah.
All the times between 0 and 10. So this t is a million different values. Question?
I thought you see this one. It's not about that. Sorry.
You're good.
Sorry. So for this integration that we're doing right here, we're trying to find like the ending point, right, to see if we can keep the lowest. So could we, instead of going from t to 0, could we go t to 8, since we're trying to find the other end? Or is that just like irrational?
We'll talk about that in a second. So hold on to that one. Sorry. Okay, look up. I'm not done here. Look. Okay, vote, please. This means I feel very confident. This means I don't. I need to see your vote. Just like this. You don't have to show everybody. Are you confident that this symbol and this symbol are different? Like they have different, completely different meanings. They're both related to time, but they have different meanings. This one, look, come on. This one is a specific chosen time. If I want to find the amount of pollution on day 10, I will put it 10 here, and I'll put it 10 here. But then when I plug this in my calculator, the calculator is going to plug into here all of the times between 0 and 10. So that's why this symbol of t and this symbol of t are different. So show me your vote, confident, not. Some people go like this.
You're super Someone's like,
No, I'm not. No. Okay, 2 points for voting. We're pretty good about 95% are feeling pretty good about it. We'll keep talking. Okay. Look out. Oh, question, please.
I just get confused when to know when you should integrate it and like put 10 there, or when to not supposed to integrate it and you're just supposed to like put it in
Like in the P prime.
Does that make sense?
Mm-hmm. Some of that just keep coming after school, keep talking about it. It really will help. But the kind of short answer is, if I plug a 10 into here, I'll be computing the rate at which P changes at that on that day. So I won't know the value of P, I'll just know how fast P is changing on that day. When I do an integral, I'm trying to find out what happened over a time period. So I'm trying to find out from day 0 until day 10. How much did the level of pollution go up, or how much did it go down over the entire 10-day period? Whereas plugging 10 in here is just like, how fast is the pollution level changing right at that moment? That's one difference. But honestly, with all these different scenarios, the best way is to just, every single time the problem feels confusing, ask me, and then we'll kind of talk one-on-one. So, okay, here's the point I'm trying to make. To avoid losing a point, when you have a variable here, if this is a number, you don't have to worry about this. But if this is a variable, you need to make this variable different, and this one as well. That's a requirement on the AP test. They're not as picky about this, so I've seen cases where they don't take away the point, but I've seen cases where they do. So safest to just make sure, don't make this variable and this variable the same. Just always make them different. So the variable I often choose to use is z. So make sure you draw a line through z so you don't forget that it's not a 2. So z represents time. Z represents time. It's just representing all the different times from 0 until 10. Whereas this t just represents time 10. The d of z. That was just a mathematical convention. Like they just decided that these are going to match. And honestly, we kind of spent 5 minutes explaining the reason. If you can't quite remember the reason, don't worry about it. Just remember they can't match.
So is this like saying from time 0 to time t, like p prime, the equation for p prime, it will take an infinitesimal, these small like numbers from 0 to t, and they will find p prime for each one of those different segments, and then d of z is just a time period, so like when this starts.
Yeah, it's doing this, Canyon, it's doing this. What's really happening when you do this integral is you're going to the calculator, you're going to time 0. This is kind of what Carrie was asking about. You're going to time 0, and you're saying at time 0, hey, the pollution level is changing by 2 gallons per day negatively. It's like it's going down. So the calculator records that. It says, okay, 2 gallons per day. But that rate doesn't really last for an entire day. So we just say it only lasts for 1/100th of a day. Okay? So when you multiply those together, you get this number, negative 0.02 gallons. That indicates that in this 1/100th of a day time period, the level of pollution went down by 0.02 gallons. Then you go forward in time and you say, okay, well, what does the rate become? What does the rate change to? So I go forward in time and go from time 0 to time 0.01. Ah, look, the rate is different. The rate's now only negative 1.94. So I write that down. Negative 1.94. I multiply that by a tiny amount of time and discover that during that next time period, the pollution level dropped again. This time by 0.0194 gallons. That's what's happening when you're integrating. You're finding little by little how much is the pollution level changing moment by moment. You add up all those changes, you find the total change in the pollution level over the entire time period.
You just bring all the small increments
together. That's all you're doing. That's all integration is. It's not complicated. It's very simple. Okay, we've got to finish this because we're down to 9 minutes. Other questions here? I never got back to your questions, so we're headed there. So, I need to find out the pollution level at time A. So I'm going to use Abby's equation to do that. Somebody's found this, I'm sure. Hint? Please, Abby. 35.114.
104.
Thank you. Like that?
Yes.
Awesome. 2 points. For it.
When I wrote that down, I didn't do P of T, I did P of A equals 50 plus 0 to A. Is that fine?
Yep.
Okay.
Yeah, if you remember here, Tori, that was the method I was using on this problem. Totally valid. I just was showing there's a different way like Abby brought up. So, good? Please.
So I wrote the way she used as well. So you don't have to do the 50.
No. This way is just great. Is that what you meant? 2 points, Garrett. So then, okay, now we got to answer Elena's question. Like, how do we deal with the fact that time just goes on forever? I'm kind of going fast because we're running out of time. What I notice is right here, look. When P prime is negative, Danica's chart tells me P will go down. When P prime is positive, P goes up. So after time 30, P is just going up. So that's what I'm going to write on my paper. I'm going to say for time greater than 30.174, P prime of T is positive, so P of T is increasing. Now I know the answer to the problem. I'm supposed to figure out at what time is the number of gallons least and what is the amount of pollution at that time. So I write P of T is lowest at T equal 30.174, don't forget the units, days. And then I write the amount of pollution on that day, 30.174. They did not tell me to round, so I don't, is equal to 35.104 gallons. Don't forget the word gallon. The red statement will earn me a point. Please.
Sorry, what's the P of A from?
So A is the time 30.
Okay.
So that's one of the times where P could be lowest. So I checked at the beginning. The amount of pollution at time 0 is 50.
Oh.
I found this from using Abby's formula by just plugging 30 into here. So now I know the amount of pollution on day 30 is 35 gallons. After that, the pollution level always goes up. I'm trying to find the lowest pollution level, so I found it. 2 points. Justin.
Instead of writing P of T, I just wrote for a lake. Is that okay?
Just read what you wrote. I'll check it.
So I said the lake at the least amount of pollutant at P equals 30.174 days.
And then did you have the following statement about
the lake has 35.104 gallons at time equals 30.174.
Perfect. Yeah, for sure. Absolutely.
So what you just wrote at the bottom, is that what you would do for justifying your answers?
The way the points work is they're going to give you one. Okay, how they give out points kind of varies, but how they gave out points on this problem is as follows. They gave 1 point for this statement right here, the green one, and that's part of the justification. They gave 1 point for having these three right here. So all of that was needed for another point. And then the final point was the red. Is that your question?
Yeah, and I'll tell you.
Please.
So where you put at the bottom P of where you put less than 4, could you put P of A in there since we already specified that A is 30.174?
Yes, 2 points. Elaine, please.
Sorry. Okay, the T that we put in that P of T equation, the red.
Right here.
Sorry, above. Sorry.
Right here?
That the T that we used was the A because it was in
Yep. Yeah, I used this equation, so I said P of 30.174 will be 50 plus the integral from 0 to 30.174. Found that number and wrote it down. Yes. 2 points. Okay, next one. Okay, I'm going to leave this on the board because we only have 4 minutes. But the questioning today, as always, like really, you do a good job every day questioning. Just don't stop questioning. I will tell you, the eyes on me. Everybody looking up. Nana, look up. Hallie, look up for a second. Okay, I can virtually guarantee you of one thing. The only reason you won't pass the AP test on May 5th is if things don't make sense to you and you don't come talk to me. Really. Like, that is the biggest reason why people don't pass. Like if things don't make sense and you come talk about it, and as long as you're willing to do what Elena did, just look at me and say no. And I don't care. Like we just keep talking, we keep talking, we keep talking until you feel it. It is all about the feeling. It is. It's like you can feel it. You can feel when it's like, well, it does make sense. And once that happens, then you're good. Then you just move forward. Just make sure you come talk to me if you need to. So, look. You want to know the greatest distance between the particle and the origin. So this is our old moving particle question. So the particle's moving back and forth. The particle's way over here at some distance from the origin. The particle's way over here at some distance from the origin. The basic idea is very simple. I'm really focused on position here, like when is the particle farthest from the origin? So I remember the Min Max Theorem, which says I can find when my position is greatest by studying when the derivative of position is 0. That's it. Plus I got to remember the beginning and the end. So that's what I wrote here. I'm concerned with time equals 0. I'm concerned with time equal 5 because that's the time period. But I'm also concerned with when the derivative of position will equal 0. That's been consistent in all three problems we've talked about today, and it is always the rule. If I'm trying to find when anything is greatest, I need to study when the derivative of that thing is 0. So I used my calculator. So I plotted the velocity, number 2. So I plotted the velocity. Don't plot it because we're kind of out of time. Just take some good notes to help you with the homework. So on my calculator, I plot the velocity. Helps if you get the right formula. Come on. 2003, number 2. That one. There we go. The window should be 0 to 5. When I look at the velocity plot, I notice that the velocity is equal to 0 at, I believe, 3 different spots. Yep. So that's what I found here. The 3 different times when the velocity is 0. And then all I have to do is what Garrett said. I'm going to go find the position at all of those times using integrals. I integrate velocity to find change in position. So the way you read this is you say, at time 2.507, the position will be, well, at time 0, the position was 1. From time 0 to time 2.5, this integral will tell me how much the position changes. Put those two together, I know the new position. And then I just look at the positions and say, well, which one is greatest from the origin? That's it. So the answer is here.